All right, so we are at topic 2 of lesson 2, which is where we're going to talk about what it means to write roots as rational exponents. And as I mentioned in the intro video, that just means that we're going to change our symbolism a little bit to make our math a little bit more organized. Because again, as you saw in class, the more complicated our expressions get working with roots, the more disorganized our own work can get. And anytime our work gets disorganized, we tend to end up with the wrong answer. So we don't like disorganization in mathematics. So mathematicians have a better way, and we're going to talk about it here in our notes. So why don't you copy down this chart for me? And as you're doing that, I'm going to remind you how we've defined exponents already to this point. So let's say we have x squared versus x cubed. Remember that exponent in each case is telling us that the number, the base of the exponent, so that would be x in this case, it tells us how many times the base should be a factor. So x squared says that x should be a factor twice. That means x times x. And x cubed tells us that x should be a factor 3 times. X times x times x. And that continues to work. If it was x to the 10th, it would mean x is a factor 10 times. Now, let's compare that to what we know about roots. If I take the square root of a number, like let's say, for instance, the square root of 9, it means that I'm looking at the factors of that number, 3 times 3, and I'm keeping only half of them. I keep the one 3, but I get rid of the other. As opposed to if I'm taking the cube root, let's say the cube root of 8, it means I'm looking at the factors of that number and I'm only keeping 1/3 of them. So like one of the 2's I'll keep, but the other 2 will go away. The answer here is 2. So square roots keep half of the factors. Cube roots keep 1 out of 3. Fourth roots would keep 1 out of 4. If I had a 10th root, I would only be keeping 1 out of 10. So that's how roots work, and we discussed that quite a bit in class. If exponents tell us how many times the base number should be a factor, and if roots give us fractions of factors, then why can't we write a root as an exponent? In other words, the square root of x, we could write that more simply, and it may not seem simple right now, but trust me, it is much more simple. If I write this as x to the 1/2 power, meaning I want to keep only half of the factors of x. Similarly, I could write the cube root of x as x to the 1/3, because I'm taking x and I'm only keeping 1/3 of the factors. And that would work for any type of root. The 4th root would be x to the 1/4. The 10th root would be x to the 1/10. Again, because I'm saying how many of the factors of x I'm going to keep, only a fraction. So rational exponents just means taking the root and rewriting it as a power. The power corresponds to the number of factors that we're keeping. Let's apply that to an expression. So let's say we had, let's say I took the number 10, and I wanted to take the square root of that number, and then I wanted to cube it. Now we're not going to solve it, we're just going to rewrite. Right now we're not solving, we're just rewriting. I could rewrite this as the square root of 10 to the power of 3. I could rewrite it as 10 to the 1/2 cubed. And if you remember, I like Maria's commentary. If I take a power to a power, I can really just multiply, and this whole expression is just 10 to the 3/2, because 1/2 times 3 is 3/2. Same thing would work if I had, let's say I took 10, I cubed it, and then I took the square root afterwards. So same expression, but in a different order. In this case, I would say I have 10 cubed, but then I want to take 10 cubed and take 1/2 of those factors, the square root. Again, a power to a power, you multiply. 3 times 1/2 is 3/2. So here we see that a rational exponent actually, let me use a different color. make it a little brighter. The power here is 3 in both cases. The root in both cases it's a square root, so it's 1/2. And so in my final answer, the top number is indicating what the power is, the bottom number is indicating what the root is. Top is the power, 3, bottom is the root, square root. So if I had something like, let's say, y squared cube rooted, what I could do is I could just rewrite this as y to the 2/3 power, because 2 is the power, 3 is the root, and so y squared cube rooted is just y to the 2/3. And this works even if I had, let's say I had the cube root of x squared times y to the 4th. I can actually just write these as separate expressions. I can say this is x to the 2/3 power, because x has a power of 2 and a root of 3, and y to the 3/4 power, because y has a power of 3. Oh, sorry, I don't want to say 3/4, I want to say 4/3. I was thinking the other way around. The power is 4 and the root is 3. So this would be x to the 2/3 times y to the 4/3. And that allows us to just take what's a little bit messy here and write it into slightly more simplified terms. I'm not sure if you're convinced yet. Hopefully you're getting the idea of just how to go back and forth between root notation and exponent notation. But I'm not sure that just with this explanation you might be convinced that this is any more useful to us. So I'm going to add on one more video, a topic 3 video, where I'm going to show you an example of one of the problems we've been doing in class, which is rationalizing a denominator, and show you how much easier it's going to be using this new notation. So you can, again, draw a line down the middle of your notes or whatever you need to do. This will be topic 3, your final portion of lesson 2.